Hey all, welcome to my next video, and in this video I'm going to talk about Monte Carlo simulation, and we are going to use the AR1 model. So to start with, I have done some part and I'll talk about that thing. So I have taken the month, the year for the import of India, and I'm going to project how the imports would look like using an AR1 model. So I'm going to use an AR1 model. I'm going to run regression of t versus t minus 1. So this is the t and this is the t minus 1. I'm going to run an AR1. So this result is AR1 result, and this is the residuals. So this is the AR1 result, and the other is the residuals. So the residual should look like past. So I have taken the standard deviation of mean of the past residuals and the standard deviation of and mean of the new residuals that I have created. So now I'm going to run 10 paths for this model. We can increase it to 100 or 1000 or 10,000, but since we have got very less data, we have got just quarterly data. So based on the data of the last 10 years, I'm going to run an AR1 model. So I have taken the slope of the AR1 model, multiplied it with the last entry, and to make it easier, let me bring that here. So these are the paths. Now I am going to add the random disturbance to this, and I'm going to pull this on the right. So if you see, we are taking the t minus 1 and the last residual. So we start from here and we go till the end. Let me see if I have taken more residuals than required. Okay, so I've taken 11 residuals, although we needed 10. And now again I'm going to use the last value for that part, and I'm going to add the normally distributed residuals. I'm going to pull this. Let me see if we are pulling the right part. Okay, and now we are going to pull this down all the way to the projected years. So I'm projecting this for 1, 2, 3, 4, 5, 6 or 7 years, although we would require a lot less projection. So these are the 10 paths that we have drawn on. So we have used the AR1 model. Let me show you what that model means. So in the AR1 model, we have taken y f t is equal to y of t minus 1 into a slope plus an intercept plus an error term. This error we got from the back data, and we took the standard deviation and variance of this error and used it to create a normally distributed random number. So this is my normally distributed random number using the formula norm inverse. A15 is the random probability, and these are the standard deviation of the projected period. So this is the residuals past, and this is the future. Let me increase this to the entire block so that we can compare the values of the entire block. So the residuals of the past had a standard deviation of 1570, and the residuals now have nearly the same thing, so I'm fine with that. And let me find out the same formula for this. So the residuals in the past had 2000, and we now have 1962. I'm also going to talk about the problems in multiple regression. So maybe let me just note this down. So we have three problems: heteroscedasticity uh, and a few more. I think multicollinearity and one more I'm tending to forget, but we'll look at them at a later stage. So these are the projected paths that we could see. Let me just try to create a chart out of them. So insert. So this is how the trait could go into the future. So let me try to bring that here. So this is how the trade would go into the future. The chances of moving here and there is small, because the AR1 model is a good fit, and the data that we have used for the AR1 model is till 2004. So from 2004 to 2013, the chances are that trade, which is I guess 364 million US dollar, would go in something like that. So I'll talk about the other part on the normalization of these numbers, but regarding the direction, this is what we are going to do. The important part that you need to understand here is the adding of error terms, because if you don't add the error terms, you will not get a disturbance like this. So if you refresh this sheet, you will see a different kind of a graph. Let me show you how. So as you can see, but I have taken only 10 paths, so based on that, this is something what we are getting. So the disturbance would come only due to this residuals, and the residuals is low. If you remember, the models that we ran the last time also were having a very good fit of 99% R square. So that did not created much problem with us. Oops, let me see why this went wrong. Okay. So this is 2013. This is okay, and the data here is 2013. I guess I should keep this from 27, 28 to make sure this works. So I'm moving the data down so that I have the 2013 numbers. So here we go. I'm always creating a version up so that I have the changes intact if I get somewhere wrong. So this is the Monte Carlo simulation of the trade, and it would grow something like this. If you look at the past on how the trade has been, so for the past, the trade has been something like this for the past 10 years. Just flipping the order, so this is like from earlier, and this is like the latest one. Let me see if I can change this. Let me add secondary axis. Where is that? Okay, anyways, I'll try to move this. So this is how it has been increased, and this is how it would look into the future. So based on our input, we have calculated how the Indian import of various things are going to move. So that import is currently standing at somewhere here. Let me see if this is the data that we use. So this is Jan 2013. We have Jan 2014 52241. Jan 2014 we have not used. Okay, so we have used it only from 2013. Let me add this and see if this is the same. Oops, I'm not getting the sum on the downside. But anyways, so we have taken the import data, we have tried to regress import, and what we found in the last session was that this import data is dependent upon a lot of things like currency, like market, the export, because higher the export is, the more money you will have. There would be something which would be related on each other, like the currency is dependent on export, so if the export increases, the currency would go in a good direction. But this has not really been the case when you look at the directions of the currency. Look here. So the export might flounder, but the currency has moved a little bit different, so it has been always better to take it as a separate variable. Now there could be three problems here with the regression here that I now want to talk about. So there could be three problems with this part. The first is if we look at the residuals. So we now should look at the residuals for the past data. If I try to look at the residuals, and this has been my residuals, and this is as a percent of the value which we are referring, the residuals has been high and it has become low. So this amounts to heteroscedasticity. Let's check that and understand what that problem means. So this problem occurs when we have got the difference in the variance of the residuals is not constant. So the possible heteroscedasticity, suppose you have got a random variable, conditional variance, hetero has not got least counts to be raised, although. So this is one problem that we have in our data. If we talk about other problems like serial correlation, so our residuals don't seems to be correlated with any of the data that has been moving, but we did not run this. So serial correlation, heteroscedasticity, and the third one was multicollinearity, where the variables are dependent on each other. So the only thing that I have problem is that the residual was very high and it has increased. So something like the variance of the residuals is not constant. So let me talk about this. Variance of residuals is increasing. So this is one issue with us that we have. So serial correlation is not a problem. Heteroscedasticity is. Let me look at it from a financial analysis term, if I can check that. So the only issue that I have is regarding my residual, which was very large in the starting and which became small at the end when I tried to run the multiple regression. So when the standard deviation of a variable monitored are constant, it refers to form conditional and unconditional when future period are low volatile. So the variance of these things, standard deviation of these numbers was different at different point in time. So the variance of the regression error are not constant, and this is what is creating this problem. But other than that, here things looks quite good enough. Let's look at the residuals and how the residuals has behaved. So the residuals have been in line. There was some spikes in between, but we did not remove the seasonality factor from here. So we will look at the seasonality factor and understand how that seasonality factor can actually create trouble for us. So the data of such type where we have got import and export would exhibit a lot of seasonality. So for the 12th month, I would take seasonality as this value divided by the average of 1 to 12. I'll fix this. And I'll bring this down. So 12 to 12. Here I will move this block here, and I'll try to bring this down to 1. So let me show you this issue with the seasonality. If you look here, the import has been high at the starting, at the ending, but they are for sure high in the Jan part. The lowest they go in 8th month. Here also they are lowest near the 8th month. So this data is having seasonality effect, and we should remove them while we run the analysis. Let me show you. Oops. So this data is seasonal, but maybe they are seasonal with quarter. Oops. Did we miss anything here? Okay, the seasonality has been broken here. It's not the least in August as it was in the earlier period. So if we could get a seasonal factor here, we would have used that seasonal factor, and we would have removed that seasonal factor. So other than that, still, as the things have been moved from up to down, and this thing that you see here is because of the recession period. So let me just get that key also into the play. So this was the recession period. Other than that, things have improved and stabilized. They have come down in the last, but probably they'll go up in the future as well. So this is the historical data, this is the projected data, and down then we have the residuals, which might go weird due to this recession. So let me add that data to understand why we might have problems here. So here we go. So in the recession time this went up. The other thing is due to seasonality. If we can find out this seasonality, we can probably remove this error. So let me check with seasonality and see if we can find a way out. First one. So I am now searching for the seasonality thing, and I will let me make sure that we don't tumble it. So 12 to 12, 12, everywhere we have 12 to 12. I see a general trend here that things do dip down in the starting and then they go up at the end. So we might have this issue with us. So let's try to change our projection to include this factor. I need to make sure that they sum up to 1 because we have taken the average, so the sum of this should be same. Let me see if we are missing something. 1 to 12, 1 to 12, count 12, average 100%, and sum 12. Okay, I think that is fine here. Now we are going to actually include this seasonality into our past projection. So what I'm going to do here is that this is our past projection. I am going to remove the seasonality from this factor, and I'm going to multiply this seasonality in my projections as well. So just be with me, this might turn a little tricky. So this is the past projection, okay, and here I multiply the seasonality. Okay, so I have multiplied the seasonality. Before that, let me make sure I add it. So I'm just changing the idea for all the data of the past. I'm going to make sure that we remove this issue, and then we are going to look at how two things work. Okay, last one. So now we have got the seasonality factor into play. Okay, now I'm going to take a mean of these seasonality factor and then use them into my equation. So let's check that is equal to, I'll take some median, this comma this comma this. Or I'll rather take mean. Okay, so this now becomes my seasonality, and this seasonality I'm going to use in the past, into the future, everywhere, and I'll find out whether the issue with the residuals got better or not. So I think I did some mistake, so I'm going to hard code this seasonality. So ideally we should take this as the average of all the seasonality factors, but for now this looks fine. Okay, so now I'm going to multiply this seasonality factor into my past data, so that all the data that I'm checking from the past has this seasonality multiplied. Okay, now to make sure that this becomes my new residuals, and if you can see, the mean of the residuals decreased, which means that this data helped us a little bit to overcome the things. And now I am going to multiply this seasonality factor everywhere in the projected period. So the entire thing that I got here, I will add the seasonality factor, and I'll make sure that the seasonality factor comes into play here, so that I get the right seasonality profile. Let's check out how that would work. So I am going to take from 1 to this seasonality factor, I'm going to take from 1 to 12, so from 1 to 12. Oops. Okay, I think I have to take the reverse of that. So 1, 2, oops. So I'll use this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So this is my seasonality factor. I'm going to use the same factor for all the periods that I'm doing the projection for. And now I'm going to multiply the final figure with this seasonality. So this final figure into this, and since I'm going to drag this, I'm going to make sure we lock this. This has got the seasonality factor. I'm going to now stretch it. Oops. Now going to stretch it. Let me check if we are multiplying it with seasonality. Yes. Yes. Are we using seasonality? Yes, we are. So this should not be used in dragging. So here we have included the seasonality factor in our projection, and that has considerably changed the regimes. So let me just refresh this. So this means that there would be a dip somewhere, and some things would happen, and that is probably due to the seasonality trend. Let me see if I can find something, because this hump does not gives a very good impression. So this hump comes out to be somewhere in between where seasonality would increase. I think this should be perfectly fine if you run it many times. Okay, let me check this. So we are at 69th. 1, 2, 3, 4. 69. 109, and we are again moving down. Again up, again down. Okay, I think that is fine, because at the 69th period, let me check, things look fine. I think they do. Okay, let me check this. I guess something wrong with the normality thing. So this should be first, this should be second. Let me check this. Okay. Let me make sure that we are using the normal distribution that reflects what we want to reflect. So this normal distribution, the average is 0.5. So this is like all the probabilities. There are 456 entries that we are using, so we want a random number between 0 and 1, and they are equally distributed. So that is the reason we'll get something as 49. Let's try to check this now. So still we are getting this hump at around 70th period. Let's check that, the 70th period, and then we are gradually decreasing. Let me see if we are using the right numbers. Yes, we are. Let me see if we are running the regression on the corrected data. So t minus 1, t. Okay, I think I got the issue. We are not running this on the data that has been removed for seasonality. So we have to make sure that we run this on the data that has been already removed of seasonality, and then run the regression. So let's check this. So I am now going to remove the seasonality out of this data. So hard coded seasonality. So remove. Alt ESF. So I've removed the seasonality of this old data, And now I need to just make sure that the t-1 that I'm using should be from the clean data. Okay, so I removed the seasonality and I have made sure that we run this on the clean data. Okay, let me see if this is better. Okay, now this is better, the upside and the downside. So after adding the seasonality, things have looked better. This residuals have decreased. This residuals is between the okay, let me check this. This is the past projected. This is between I5 to D5. So this is using the real data, yes. The past projected is t-1 using the slope into seasonality. Okay, this is again the past projected data t-1. We need to make sure that this is not into seasonality. We have removed the seasonality, so we have to actually get the past projection from the unclean data. So the past projected here should be this. Past projected here should be this. So bringing this down, and now we can get the real projected. So this is the past projected, okay, and this is the real projected. Okay, let's try to check. So the mean of the residuals has decreased some bit after doing all this. Let's see the projections. So projections have added those seasonality factor. We have tried to play around with this. Let me just save this and let me open an earlier version to see if things have improved or not after adding this seasonality. So let's open V14. I don't know if we might have the residuals. We have the residuals. So the residuals average 2020, and the seasonality profile, oh, we did not do it, but this mean of the residuals was 2020. After doing all this, we were able to reduce it to 150 points. Moreover, we added the seasonality for the future, so that whatever values we get in the future is actually having that seasonality. Okay, so we looked at seasonality, AR1 model, what to do of different months, how to take the seasonality factor out from the equation, how to find out the residuals, and how to project data for the future. So the best projection that we have till now would look something like this, which means that in the next 12 months the trade would go something like here. Before we end, let me talk about the mean of this data, which would be quite an interesting thing. So this is the mean path. By mean path I mean that if you want to draw a single line for the future, then you could use this line, and this line would reflect what the trade would go in the coming time. Oops. So I'm going to now include this mean path in our analysis. So let me draw the mean path for various months and let me check how this looks. So this is the mean path. In terms of the Monte Carlo simulation that we have been doing, we have found out how things could vary. But if things don't vary, then we would have something like this. Let me insert a trend line here. So a linear trend line. So the trade would increase something like this in the coming years. And this should be a linear path based on 10 path. This is very sensitive to the way in which we change things, but the whole idea remains is that after some time, let me try to so this data here, if we add a linear trend line, and let me have the statistics here as for the slope as well, so that you can find that out regarding how fast things are moving. So linear trend line, display the bottom chart, display in the bottom chart. So this is something like this. If we look at this past data, and if we go there and if we draw a linear trend line, so this linear trend line has got a faster intercept, but we have tried to remove this seasonality, and this seasonality profile has changed everything. So the slope that we get from the past is this. So let me just check if we did anything wrong. So we took a slope of removed, and this should be removed. Yes, we took the slope of removed versus removed, and we took an import of removed seasonality. So this is how things would look like. This is how the trade would do. So we have done an AR1 model. There would be other models which we could use, but this is among the simplest of all. The idea still remains that things were growing at this pace, and let me check before the seasonality how things were poised. So this was the slope for the AR1 model and the past, and now this slope has become a little less because we have removed the seasonality, so that spike for the end has just reduced down. So I hope this was helpful to you. We looked at a comprehensive review for Monte Carlo simulation. We looked at AR1 model, we looked at seasonality, we looked at how to take the average of the data, and we looked at how to project the future. So based on this model, what we project is that say after 80 months, and by 80 months I mean around 6 years, the import of India would grow from this 400,000 to say about 600,000. So this is what we are projecting using the AR1 Monte Carlo simulation model. So thank you for watching, and let me know if you have any doubts. Bye bye.